Hi there, in this video I'm going to explain two methods for numerical integration. Okay, so there's many methods that we can use for numerical integration, but I'm going to explain two of them. The first one is trapezium rule. Okay, so let me explain to you the idea behind the trapezium rule, and I think a couple of prepared screenshots is in order. So let's have the first screenshot. So in this screenshot, supposing if we have the curve y equals f of x, okay, and in the next screenshot, supposing if I wanted to work out the area under the curve, so the area under the curve y equals f of x between two lines with equations x is equal to a and x is equal to b, okay. So we're going to work out the area capital A between the two lines and below the curve. Now, the idea with the trapezium rule is we first divide this area into n trapezia of equal width h. So note that the widths of each trapezia are equal, okay? And we use the values of x. So the first x value, I normally take that to be x0, so I use x0 to be the starting value of x, and x0 will be a, okay, and the final x value will be b, so final x value, I'll take that to be xn, the last x value, that will be b, okay, and I want you to have this in your mind. Now each of these trapezia has equal widths, okay. So the widths of all of these trapezia are equal, they all equal h. So if the first x value is x0, to work out the next x value, x1 will be x0 plus h. In the same way, x2 will be the previous x value, which is x1 plus h. And x3 will be the previous x value, which is x2 plus h, and so forth until you reach the last x value, which is xn, and xn is the value of b on the previous screenshot, okay. We need these x values in order to work out the corresponding y values, and let me explain why we need the y values. So over to the next screenshot. We need the y values purely because the idea of the trapezium rule is that if we add the areas of each of these individual trapeziums, we're going to find an approximate area, okay, for the area under the curve between the two lines x equals a and x equals b, okay. Now you may know this, so at a GCSE or school level, the area of a trapezium is given by the formula half of the sum of the parallel sides multiplied by the distance between them. So the parallel sides, I've labelled them A and B, so these are the lengths of the parallel sides, and the distance between the parallel sides is labelled h. So it's half of A plus B, the sum of the parallel sides, multiplied by h, the distance between them. Over to the next screenshot. So in order to work out the area A under the curve y equals f of x between the lines x equals a and x equals b, what we need to do is we need to add, as I said before, the areas of each of these individual trapezia, okay. So we need to add the areas A1 all the way until we reach AN, the area of the last trapezia. So using the formula, area of the trapezium is half sum of the parallel sides times the distance between, okay. I've added the areas of A1, A2, A3 all the way until I reach the last area, AN. And if you take a common factor, so if you take a common factor of h over 2, you're going to end up with the formula for the trapezium rule, okay. So the formula is a equals h over 2 multiplied by y0 plus yn plus 2 times y1 plus y2 until you have the y value before the last y value. Okay, the way that I memorise this is it's h over 2, so it's width over 2 multiplied by the first and the last y values. So the first y value is y0, the last y value is yn, plus 2 times the sum of the remaining y values, excluding the first and the last. Now the formula for h is the width of each of these trapezia. H is b minus a. Okay, so b minus a comes from the x values that you're given in the question. So between our lines x equals a and x equals b. Okay, divided by, now n is the number of ordinates. So the capital N is the number of ordinates that relates to the number of x values or the number of y values. So that explains the idea of the trapezium rule. So I hope that makes sense. So it gives you an idea in terms of where the trapezium rule comes from. So back to the paper and pen. Let me explain another rule. So here's another method for numerical integration known as Simpson's rule. Okay, so let me take a ruler and a red pen and underline this. So in order to work out capital A, the area, using Simpson's rule, it's h over 3. Okay, so it's h over 3 multiplied by the first and the last y values, so y0 plus yn, okay, plus 4 times the sum of the odd y values, excluding first and last. So sum of the odd y values means y1 plus y3 plus y5 and so forth and so forth. Okay, so again excluding the first and last y values, plus 2 times the sum of the even y values, again excluding first and last. So even means y2 plus y4 plus y6 and so forth and so forth. Okay, so that is the formula for Simpson's rule. The formula for h is the same as we've seen with the trapezium rule. The formula, remember, it's b minus a divided by capital N minus 1. And remember the idea of capital N. N is the number of ordinates. So it's the number of ordinates. Ordinates means the number of x or y values. Okay, so it's the number of x values which is the same as the number of y values. Okay, so let me highlight this. So this is the formula for trapezium rule. I'm not going to go through the derivation of the trapezium rule. It comes from interpolation, and there's plenty of books, good books and websites out there that explains Simpson's rule, so I'm not going to go through the derivation. Okay, however, in the next video I'm going to go through examples explaining and showing to you how the trapezium and Simpson's rule is applied.